let's talk about molar mass. So before we do any calculations, molar mass is, we're going to define it, it is the mass, typically in grams, but of course we could use kilograms or a different version, but just typically whenever we talk about molar mass, it's always going to be in grams. So it's the mass of 1 mole of a substance. So every single time I have 1 mole of water, it has the same exact mass. And that mass is known as its molar mass. And remember that 1 mole is 6.02 times 10 to the 23rd particles. So 6.02 times 10 to the 23rd molecules of water always has the exact same mass, its molar mass. We get molar masses from the periodic table. So if we just have a single element, it's rather simple. So let's start with this example, carbon. The molar mass for carbon, we bring in the periodic table, we find carbon on the periodic table, and it's 12.01. Anytime we have that small of a decimal next to our number, we usually just go ahead and round it. But if you're not sure about your rounding skills, then just write down the exact number. So the molar mass for carbon is 12, and the units for molar mass, since it's the mass of 1 mole of a substance, grams per mole. So the units are grams per mole. So there are 12 grams per every 1 mole of carbon atoms. That's the mass of it. All right, oxygen gas. So oxygen appears naturally as O2, not just as O. It's a diatomic. We learned that in the last unit. So oxygen is O2, which means its molar mass is not simply just looking at oxygen and seeing that it's 16. Well, we don't just have 1 mole of oxygen atoms because there are 2 oxygen atoms for every 1 O2 molecule. So we actually have to multiply 16 times 2, and we get 32 as the molar mass for oxygen molecules. Now, had this specifically said just oxygen atoms, then it just would have been 16. But it's asking for oxygen gas, which is elemental oxygen, diatomic, O2. So 16 times 2, 32 grams per mole is the molar mass of oxygen gas. Water, we have 2 elements here. We have 2 atoms of hydrogen combining with 1 atom of oxygen. So we want to know the molar mass of this entire molecule. So 2 hydrogens, 1 oxygen. The molar mass of a single hydrogen, if we go to the periodic table, is basically 1.008, but I'm going to round that off to 1. So we have 1, but we have 2 of them, so we've got to multiply that. And then oxygen, we just looked at it, is 16. So we don't need to multiply it by anything because I just have 1 oxygen. So I add these together, 16 plus 2, and I get 18 grams per mole for the molar mass of water. And then for this last one, this is calcium carbonate. So this is an ionic compound. We would not call it a molecule. But for this compound, I've got 3 different atoms. I've got 1 atom of calcium, 1 atom of carbon, and 3, don't know why I wrote that over there, 3 atoms of oxygen. So again, go to the periodic table. Calcium is 40, and I've just got 1 of those. Carbon is 12, we used that earlier. And then oxygen is 16, but I've got 3 of them. So 16 times 3, I didn't crunch all these numbers beforehand, my bad. Bring in my calculator. So 16 times 3, we've got 48. I guess I kind of knew that, but all right. And then we add 40, 12, and 48. And we actually get a grand total of 100. So our molar mass is 100 grams per mole. And that's how you calculate molar masses.